In this lecture, we're going to study dot and cross diagrams for ionic compounds. But those ionic compounds, the only difference is that now the charges would be uneven. Previously, what we studied was that we drew a dot and cross diagram between a group 1 and a group 7 element. Now, group 1 loses 1 electron and group 7 gains 1 electron. So it had a -1 charge by gaining 1 electron, and group 1 got a +1 charge by losing 1 electron. So everything was balanced. The number of electrons lost, the number of electrons lost and gained were equal in the previous examples that we did, but now the number of electrons gained and lost are unequal. So we're going to study cases in which the number of electrons gained or lost are unequal. The first case we're going to take is, let's think of a metal, and that metal belongs to, we have a metal and it's belonging to group 2, and that metal is magnesium, which is 12 and 24. So that's magnesium, and we have a non-metal which belongs to group 7, and it's fluorine, and it has a proton number of 9 and an atomic mass of 19. So we're going to try and draw the dot and cross diagram between magnesium and fluorine. Let's draw the diagrams first. Magnesium has, this is the nucleus of magnesium. It has 12 protons and it has 24 minus 12. There are 12 neutrons. The electronic configuration of magnesium is that it has a total of 12 electrons. So if it has 12 electrons, then the electronic configuration would be, there would be 2 electrons in the inner shell, there would be 8 in the second shell, and there would be 2 in the last shell. For fluorine, we can write this for fluorine as well. Fluorine has a total of 9 electrons, so there would be 2 in the inner shell and there would be 7 in the outer shell. So keeping that in mind, let's draw the magnesium atom, the atomic structure of a magnesium atom. I'm drawing it. This is the first shell. This over here is the second shell, and then we have this third shell. I'm going to draw the structure. There would be 2 electrons drawn with dots in the first shell. There would be 8 in the second shell, and there would just be 2 electrons in the third, the outermost shell. Similarly, we can draw the atomic structure of fluorine. Fluorine has, now it has 9 protons and it has 10 neutrons in its nucleus. It's 19 minus 9, that means it has 10 neutrons, and only 2 of its shells would be occupied. So that's your fluorine atom. There would be 2 electrons drawn with crosses in the first shell, and there would be 7 electrons in the last shell. Now magnesium, both electronic configurations are unstable. Magnesium needs to lose 2 electrons, but fluorine just needs, it has 7 electrons in its outer shell. To complete its outer shell, it needs to gain 1 electron. Now there's a slight difference now from the previous examples. Magnesium would lose these 2 electrons, but only 1 of these electrons would be gained by fluorine. Where would the other electron go? For the other electron, you would need since there are two electrons being lost and only one of the electrons are being gained by fluorine, there has to be another fluorine atom for it to gain electrons. So let me redraw this now, and let's draw the ionic structures now. Now magnesium would lose its two outer electrons. So if magnesium loses its two outer electrons, then magnesium, having 12 protons and 12 neutrons, it would have 2 electrons in its outer shell. It would have and it would have 8 electrons in its second shell, and since it has lost 2 electrons, so magnesium would have a charge of this would be Mg plus 2, and it's plus 2 because it has lost 2 electrons. Similarly, fluorine, let's draw fluorine. It's having 9 protons and 10 neutrons. That's fluorine. Now the number of electrons, the 2 electrons in the inner shell, and it had 7 electrons in its outer shell. So those are the 7 electrons. One of the electrons, magnesium lost 2 electrons, fluorine needed 1 electron. So one of the electrons came from magnesium, so that's drawn with a circle. And when it gains 1 electron, it will become -1, negatively charged. So one of the outer electrons went to this fluorine. This is F -1. Where did the other electron go? So there has to be another fluorine atom which would have 9 protons and 10 neutrons, and it would have in its inner shell there would be 2 electrons in the inner shell, and it's going to have an outer shell, the second shell, which had 7 electrons, and one of the electrons came from this magnesium atom because it lost 2 electrons. So since it's coming from that side and it's gaining 1 electron, so this would also be -1. So you're going to have 2 fluoride ions because magnesium lost 2 electrons, so there should be 2 fluorines because each fluorine gains just 1 electron. So 1 electron goes to this one and 1 electron goes to the other fluorine ion. This loses 2 electrons, 1 goes to this one and the other one goes to this one. So the formula of magnesium fluoride would be that there would be 1 Mg plus 2 and there would be 2 fluoride ions. Remember, a small 2 or small number in the chemical formula, small number which appears at the bottom of the element, that indicates that atoms are chemically joined together. Another way that you can represent magnesium and fluorine, the dot and cross diagram between the ionic bond showing magnesium fluoride, would be that instead of drawing 2 fluoride ions twice, what you can do is you would simply multiply this by 2. That would mean magnesium loses 2 electrons and you have 1 fluorine atom that's gaining 1 electron, forming -1 ion, then there would be 2 of these, so that means each fluorine would be gaining 1 electron, so that would be a total of 2 electrons gained. And one easy way to figure out how many atoms we should draw, the number of atoms, because we need to keep, what we are basically trying to do is we're trying to keep the number of electrons gained and lost should be equal. So we are trying to keep the number of electrons gained and lost equal. So to one easy, a very clever shortcut is, whenever the charges are unequal, simply what you can do is multiply this. Magnesium has a charge of +2. Take this 2, multiply the fluoride ion by 2. Fluorine has a charge of -1. Take this 1 and you would multiply the magnesium ion by 1. So that would mean that you would have 1 magnesium ion and you would have 2 fluoride ions. So this is a very clever shortcut. Instead of figuring out how many electrons are lost, for example, 2 electrons are lost by magnesium and 1 electron is gained by fluorine, and to keep the electrons equal, you have another fluorine atom which is going to gain 1 electron. So instead of going into details, the simple shortcut is magnesium is going to form +2, fluorine is going to form -1. Bring this 2 over here, multiply this by 2, and bring this 1 over here, multiply this by 1. So you would have 1 magnesium ion and you would have 2 fluoride ions. And this would be the dot and cross diagram representation of magnesium fluoride. Now let's do another example of, let's say, lithium, which we have lithium Li, which is 3, the proton number is 3 and the atomic mass is 7, and it is part of group 1. It's a metal. And we'll have a non-metal, which is oxygen, which is in group 6, and it has a proton number of 8 and an atomic mass of 16. So you have lithium and you have oxygen. Now let's quickly draw the structures first. This is the nucleus. Lithium has 3 protons and it has 4 neutrons. 7 minus 3, that's 4. There would be, it has a total of 3 electrons, so that means it's going to have 2 electrons in the first shell, and there's going to be there would be 1 electron in the second shell, which is the outermost shell. And group 1, it has 1 valence electrons. That means that it needs to get a stable configuration, to complete its outer shell, it needs to lose 1 electron. And similarly, we can draw oxygen. And oxygen has 8 protons and it has 8 neutrons. It has 8 protons and 8 neutrons. The total number of electrons in oxygen are 8. It has 2 electrons in its inner shell and there are 6 electrons in its outermost shell. And oxygen should be drawn with crosses, so I'm going to draw these electrons with crosses. So there are a total of 6 electrons in oxygen. And if you look carefully, oxygen needs 2 electrons to complete its outer shell. It's in group 6, so oxygen would need 2 electrons. Now lithium is losing 1 electron, so 1 electron can come from lithium. Where would the other electron come from? So there needs to be another lithium. So there would be two lithium atoms, and since one is losing one electron, so two would lose two electrons. So now the number of electrons gained and lost would be equal. One lithium is going to lose one outer electron. There would be another lithium that would also lose one electron. So you'll have a total of two electrons being lost, and one oxygen is going to gain two electrons. So if I redraw the atomic structures of these, lithium would lose one electron. So you'd have lithium. There would be two electrons in its first shell, and there would be now I'm going to redraw lithium. Lithium had three protons, and it had four neutrons, and it had two electrons in its first shell. There were two electrons drawn with circles, and it had one electron in its outermost shell, but that one electron is now lost. It has been given away to oxygen. So since that electron is gone, it has lost one electron. So lithium would have a charge of +1. So you'll have Li +1. This is the electronic configuration atomic structure of Li +1. On the other hand, you have oxygen, which had 8 protons, and it had 8 neutrons. And this is oxygen. The electrons in oxygen, there were 2 electrons. There were 2 electrons drawn with crosses in the first shell, and there were 6 now there were 6 electrons in the second shell, but since 2 electrons are coming from one electron was lost by one lithium, and there were 2 lithium ions, that would mean there would be a total of 2 electrons lost by 2 lithium ions. Now the oxygen's electronic configuration is complete, has gained 2 electrons, and since it has gained 2 electrons, we're going to draw square brackets and write -2 on top of that. So this would be oxygen -2. So there would be 2 lithium ions, each losing one electron, and there would be one oxygen ion, and one oxygen ion atom would be gaining 2 electrons. So the amount of electrons lost and gained are equal now. The formula of this would be Li 2O. Remember, we use a small 2 whenever it's whenever substances are chemically combined together. So instead of using the larger 2, when we write the formula, we're going to use this small 2. So there would be 2 lithiums and one oxygen ion in this, and the name of this would be called lithium oxide. Now you can also check the other method of figuring out how many atoms of a particular element should there be in one compound. Oxygen had a charge of -2, lithium had a charge of +1, and I told you the simple trick is just bring the 2 over here, multiply. There would be 2 lithium atoms, each one would be losing one electron to form lithium ions, and since this is 1, so there would be one oxygen atom, and one oxygen atom would be gaining 2 electrons to complete its outer shell. So there would just be one oxygen atom. So to figure out how many atoms there are, simply look at the charges. If it's -2, and if the charges are unbalanced, if it's -2, bring the 2 over here, multiply it, there should be 2 lithiums, and if the charge is 1, there should be 1 oxygen. Now let's do a slightly more difficult ionic compound. Let's look at magnesium and nitrogen. We're going to try and draw the ionic compound that is formed between magnesium, which is in group 2, and nitrogen, which is in group 5. So you have Ng, the proton number is 12, the atomic mass, atomic number is 24. Atomic mass is 24. You have nitrogen, which has 7 proton number, and its atomic mass is 14. So we're going to try and draw the ionic compound formed between these two. If you look at, let's draw magnesium first. Magnesium. Now magnesium has 12 protons and it has 12 neutrons. And its electronic configuration is there are two electrons in the first shell. There are 8 electrons in the second shell, and there are 2 electrons in the last shell. Now, for a stable, this is an unstable electronic configuration. For stable electronic configuration, Mg needs to lose its outer 2 electrons. So it needs to lose 2 electrons. If it loses these 2 electrons, it would become a stable electronic configuration. Similarly, we can draw the electronic configuration of nitrogen, which is, you'll have, this is the nitrogen nucleus. It has 7 protons and it has 7 neutrons, and there's 7 electrons in total. So that means that there are 2 electrons in the first shell. And since there are 7 electrons, so there are 5 electrons in the second shell. And if you look at nitrogen, it has 5 electrons. To have a stable configuration, nitrogen needs to gain 5 electrons, not 5 electrons, sorry. It needs to gain a total of 3 electrons to get a complete outer shell. It needs 8 electrons, so it needs 3 more electrons to complete its outer shell. Now the problem is, you have one magnesium atom, it's losing 2 electrons, and you have one nitrogen atom, it's trying to gain 3 electrons. What's going to happen is, let me simplify this. Let's say this is a magnesium atom and this is a nitrogen atom, and magnesium is trying to lose 2 electrons. Now one magnesium, as I've shown you, it's trying to lose 2 electrons. Now one magnesium is trying to lose 2 electrons, but nitrogen needs 3 electrons. So nitrogen needs 1 electron from somewhere else. It needs 3 electrons in total. So to give it 1 more electron, you would need to have another magnesium. But the problem is, if this magnesium gives 1 electron to this nitrogen, there would still be, magnesium is still going to lose 2 electrons. So this magnesium would still end up losing 2 electrons. So that 1 electron has no place to go. So you would need another nitrogen, which would then gain that 1 electron. But this nitrogen needs 3 electrons in total. So you need 2 more electrons. So you will draw another magnesium, and that magnesium now loses 2 electrons. And now the number of electrons lost and gained are equal. This nitrogen is gaining 3 electrons in total. This nitrogen is also gaining 3 electrons in total. This magnesium is losing 2 electrons. This is losing 2 electrons, and this is losing 2 electrons. So you would have 3 magnesiums and you would have 2 nitrogens. 1 magnesium loses how many electrons? It loses 2 electrons. 3 magnesiums would lose 6 electrons. 1 nitrogen, it gains 3 electrons. 2 nitrogens would then gain 6 electrons. So if you look at this, you would realize that now the number of electrons gained and lost are equal. The number of electrons gained by 2 nitrogens is 6 electrons. Number of electrons lost by 2 magnesiums is also 6. So we can move on to drawing the structures of the ionic compound formed between magnesium and nitrogen. Now magnesium would have 12 protons and 12 neutrons. That's your magnesium nucleus. There would be the first shell has 2 electrons. The second shell is also going to have, it's going to have 8 electrons, and magnesium would lose its outermost shell which had 2 electrons. So now if it loses 2 electrons, it would have a charge of +2. So you're going to draw square brackets to show the charge, which is +2. Similarly, nitrogen would have it would have 7 protons and 7 neutrons. There would be 2 electrons drawn with crosses in the first shell, and there would be five electrons in the second shell, and this would gain 3 electrons which would come from magnesium, and it will have a charge of -3 if it gains 3 electrons. So this would have a charge of -3, and what we've just discussed previously, there should be 3 magnesiums, because 3 magnesium would lose, one loses 2 electrons, so 3 would lose a total of 6 electrons, and you would have 2 nitrogens. One nitrogen gains 3 electrons, 2 nitrogen would gain a total of 6 electrons. Now the number of electrons gained and lost are equal, and the shortcut is, instead of figuring out and calculating the number of electrons gained and lost, what you can simply do is, if the charges are unequal, this was -3, so if this is 3, then simply you should have 3 magnesiums, and this is 2, that would mean that you should have 2 nitrogens. So you have 3 Mg plus 2 ions, and you have 2 N-3 ions, and the formula of this compound is going to be Mg3N2. You use a small 3 and a small 2 to indicate that they are chemically joined together, and the name of this compound would be called magnesium nitride. Remember, the negative ion, the name changes, and you add a suffix which is IDE. So whenever it's IDE written, you're talking about the negative ion, the anion. Now another difficult ionic compound is to draw the structure of an ionic compound is aluminium, and is between aluminium and oxygen. You have aluminium, and you have oxygen. Aluminium is Al, it's in group, this is in group 3, and oxygen is in group 6. The proton number, atomic number is 13, the atomic mass or nuclear number is 27 for aluminium, whereas for oxygen it is 8 and 16. So you have aluminium and oxygen. Let me first draw the atomic structures of aluminium and oxygen. Aluminium is going to have 13 proton and it's going to have 14 neutrons. 27 minus 13 is 14. It's going to have a total of 13 electrons. The first shell has 2 electrons. The second shell is going to have 8 electrons, and the last, because there are a total of 13 electrons, the last shell is going to have 3 electrons. Now if you look at aluminium, it's an unstable electronic configuration. To become stable, it needs to lose 3 electrons. And we're going to draw oxygen now. Oxygen is, this is the nucleus of oxygen. It is going to have 8 protons and 8 neutrons, and there would be 8 electrons. There would be 2 electrons would be in the first shell, and there would be 6 electrons in the second shell. So oxygen needs 2 electrons to complete its outer shell. So the number of electrons gained and lost are not equal, and let's simplify this. There's aluminium and there's oxygen. Aluminium is losing 3 electrons, whereas oxygen just needs 2 electrons. So aluminium gives 2 electrons to this oxygen, but there's another aluminium electron which has no place left to go. So that 1 electron, you would have to bring another oxygen in. That 1 electron goes to this oxygen, but that oxygen needs 2 electrons. So there should be another aluminium, and that aluminium is again going to lose. It's going to lose 3 electrons. It's going to give 1 electron to this oxygen because this oxygen needed 1 more electron, and you're still left with 2 electrons coming from aluminium. For those 2 electrons, you would create another oxygen. You would have another oxygen that's going to gain 2 electrons. So now 3 oxygens in total are going to gain how many electrons? Each one gains 2 electrons. So 3 oxygens are going to gain a total of 6 electrons. Whereas 1 aluminium was losing 3 electrons, 2 aluminiums in total are going to lose 6 electrons. So 6 electrons are lost and 6 electrons are gained by oxygen. So you would have 2 aluminium atoms and you would have 3 oxygen atoms. So redrawing this and redrawing the structure dotted cross diagram for the ionic compound, you have aluminium, which is having 13 protons and 14 neutrons, and it has it has 2 electrons in the first shell drawn with circles, and you have 8 electrons in the second shell, and there were 3 electrons in the last shell which have been lost. So if they are lost, there are 3 electrons lost. Whenever electrons are lost, you get positive charge. So this would have a charge of +3. It has lost 3 electrons. Similarly, you have oxygen, which has 8 protons and 8 neutrons. The first shell has a total of 2 electrons. The second shell The second shell has 6 electrons, and it's going to gain 2 electrons, which will be drawn with circles, and it's going to get a charge of -2. So this is going to gain 2 electrons. Now, this has lost 3 electrons, this has gained 2 electrons, and previously what we have discussed is that there should be 2 aluminiums and there should be 3 oxygens. Now, 2 aluminiums would lose a total of, each would lose 3 electrons, so 2 would lose a total of, they would lose a total of 6 electrons, and you have 3 oxygens. One gains 2 electrons, so 3 are going to gain a total of 6 electrons. So now the number of electrons gained and lost are equal, and this would be the ionic representation of aluminium, which is ionically bonding with oxygen. We could simplify this by the easier method was that if the charges are unequal, this is +3 and this is -2, just bring the 2 and multiply this by 2, and this is 3, so just get this 3 and multiply, there should be 3 oxygens and there should be 2 aluminium. So you can simply take the charges, if they are unequal charges, make this 2 and make this 3. There should be 3 oxygens, there should be 2 aluminiums. That's the shortcut. So the formula of this compound is going to be Al2O3, and it would be called aluminium oxide. So this is called aluminium